All right, let's do some more examples. If you noticed in those last several examples, the sine, cosine, and tangent could be negative. We can figure that out using a reference angle. The reference angle is the angle between the terminal side and the x-axis. So you see over here, the terminal side is here, and the reference angle goes to this x-axis. It's right there, just to the nearest. It's always the x-axis. And it has the same values of the trig functions as the first quadrant angles. So if you know, say that reference angle is 30 degrees, you can use a special right triangle as if it was up here at 30 degrees, or whatever the angle is. You just have to add negative signs. Now this little diagram tells you what is positive. So when it says all, that means sine, cosine, and tangent, they're all positive. For this one, sine is positive, cosine and tangent are negative. Quadrant 3, tangent's positive, sine and cosine are negative. And quadrant 4, cosine's positive, sine and tangent are negative. So this is telling you what is positive. Way to remember this is all students take classes. All students take classes. Tells you what's positive in which quadrant. All right, let's sketch the angle and then find its reference angle, 150 degrees. Well, let's add our degrees here. 150 is between 90 and 180, and it's closer to the 180, so say about there. The reference angle goes to the nearest x-axis. That's the reference angle right there. So to find that measure, we just need to subtract the two measures of the sides. So 180 minus 150 is 30 degrees. Let's try negative 7 pi over 9. Oh, wait. We need, that's in radians. There's no degree symbol. So let's make those go away and pull up radians. In radians, it's 0, pi over 2, pi, negative 3 pi over 2, and 2 pi. Wait, negative 7 pi, that's not on there. This goes from 0 to 2 pi, and my question is negative. So let's find a coterminal angle, so it's between 0 and 2 pi. I suggest every time you have an angle that is not on the circle, you need to go ahead and find a coterminal angle so that it is on the circle. So I need to add 360 degrees. Oh, but I'm in radians, so I'm going to add 2 pi. So negative 7 pi over 9 plus 2 pi. I need a common denominator. So negative 7 pi over 9 plus 18 pi over 9. Multiply the top and bottom by 9. Gives me 11 pi over 9. So that's 1 2/9. So that's a little bit more than 1 pi, but less than 1.5 pi. So it is approximately there. The reference angle would be there. And to find that reference angle, I subtract the two sides of the angle. Subtract those two. 11 pi over 9 minus pi. Get a common denominator. So this would be 9 over 9. So 11 pi over 9 minus 9 pi over 9 is 2 pi over 9. So the reference angle is 2 pi over 9. All right, let's try this one. Evaluate cosine of negative 60 degrees without a calculator. Now there's several ways of doing it. Since it's a special angle, you could use the special right triangles. I'm going to show you the full process of how you think about this, how you should be thinking about this. Now it may seem kind of long, but each step is really short and you do most of it in your head. First of all, it's negative 60 degrees is not between 0 and 360. So I'm going to get a coterminal angle for that negative 60 degrees. So since it's negative, I'll add 360 and end up with 300 degrees. Draw that on my axes. Find the reference angle. Reference angle goes to the nearest x-axis. It's right there. 360 divided by, or minus the 300 gives me 60. So the reference angle is 60 degrees. All right. So now let's find cosine of 60 degrees. We can use a special right triangle. .30, 60. The sides are 1, 2, square root of 3. Cosine is adjacent over hypotenuse. So cosine of 60 is 1/2. Then we think, oh wait, we're in quadrant 4 because our angle is down here in quadrant 4. And what's positive down there? Oh, it's all students take classes C, cosine. Cosine's positive in quadrant 4. So that means our answer should be positive. Therefore, it is positive 1/2. I just took the 1/2 from there. It's positive, so I kept the positive 1/2. Estimate the horizontal distance traveled by a red kangaroo who jumps at an angle of 8 degrees with an initial speed of 53 feet per second, which is about 35 miles per hour. Now this has very little to do with anything else other than, hey, the book decided to throw it in. We use what's called the range equation. Our distance equals v squared over 32 sine of 2 pi, where v is in feet per second, which I gave you. So this is our v, and this is our theta. Just plug it in, run it through your calculator, get 24.2 feet.